Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss surface areas and volumes. In this chapter, we are going to discuss the concepts of exercise 13.1. Okay, my dear children. In the previous class, we have discussed measures of central tendency, how to find mean and median of a given data. I hope you have understood the concepts of exercise 14.4, and I hope you have learned well the sums based on finding mean and median of a given data. Haven't you, my dear children? Right. Now come to these concepts of exercise 13.1. Are you ready to listen the class? Right. Wherever we look, usually we see solids. So far, in all our study, we have been dealing with the figures that can be easily drawn on our notebooks or blackboards. These are called plane figures. Understood this point, my children? Which figures are called plane figures? Yes, the figures which can be easily drawn on our notebooks or blackboards. Such figures are called plane figures. Okay, my children? Right. We have understood what rectangles, squares and circles are. In the earlier classes, we have understood what plane figures are called rectangles, what plane figures are squares, and what plane figures are called circles. What we mean by their perimeters and areas, and how we can find them. We have already learned how to find perimeter and areas of rectangles, squares and circles in earlier classes. Haven't you, my children? Right. We have learned these in earlier classes. It would be interesting to see what happens if we cut out many of these plane figures of the same shape and size from cardboard sheet and stack them up in a vertical pile. If we arrange these plane figures of the same shape and same size from cardboard sheet and we arrange them vertically in a pile, what would happen? By this process, we shall obtain some solid figures, briefly called solids. Okay, my children, these figures are called solid figures, or briefly they are also called solids, such as a cuboid, a cylinder, etc. These are some examples of solids. In the earlier classes, you have also learnt to find the surface areas and volumes of cuboids, cubes and cylinders. Have you, my children? You have already learnt to find the surface areas and volumes of cuboids, cubes and cylinders. We shall now learn to find the surface areas and volumes of cuboids and cylinders in detail and extend this study to some other solids such as cones and spheres. Okay, my children, we extend this concept to find the areas, surface areas and volumes of some other kinds of solids such as cones and spheres. Okay, my children, is this point clear? Right. In this first exercise, that is in the 13.1, we mainly focus on finding surface area of a cuboid and a cube. Okay, my children, right. Have you looked at a bundle of many sheets of paper? How does it look? Does it look like what you see in figure 13.1? Yes or no, my children? If you look at a bundle of many sheets of paper like this, It looks like a solid that makes up a cuboid. Yes or no, children? This solid figure is nothing but a cuboid. How much brown paper would be needed if you want to cover this cuboid? Let us see. To cover this cuboid, how much sheet of brown paper would be needed? Okay, my children, right. First, we need a rectangular piece to cover the bottom of the bundle. That would be as shown in figure 13.2a. See this rectangular piece, my children, to cover the bottom of the solid. Okay, my children, right. Then we would need two long rectangular pieces to cover the two side ends. Now it would look like 13.2b. See here, my children. Here we want two more long rectangular pieces to cover sides. Yes or no, my children? Right. Now to cover the front and back ends, we would need two more rectangular pieces of a different size. See here, my children. To cover this side and this side, front and back. To cover the front and back of that cuboid, we want two more rectangular pieces of a different size. With them, we would now have a figure as shown in figure 13.2c, like this. We required these two rectangular pieces. Yes or no, children? This figure, when opened out, would look like 13.2d, like this. If you open this rectangle of four rectangles, it would like this 13.2d figure. Finally, to cover the top of the bundle, we would require another rectangular piece exactly like the one at the bottom, which if we attach on the right side, it would look like figure 13.2e. So if we add the rectangle of the same size at the right side, it will look like this. Okay, my children. So we have used 6 rectangular pieces. How many rectangular pieces were used to cover that cuboid, my children? Yes, 6 rectangular pieces to cover the complete outer surface of the cuboid. Yes or no, my children? Right. This shows us that the outer surface of a cuboid is made up of 6 rectangles. In fact, rectangular regions called the faces of the cuboid. Okay, my children, these rectangular regions are said to be faces of the cuboid, whose areas can be found by multiplying length by breadth for each of them separately and then adding the 6 areas together. Understood this point, my children? To find the total surface area, we have to find the area of each rectangle separately and we add them. Then we get the total surface area of the cuboid. Now if we take the length of the cuboid of A as L and breadth as B and the height as H, then the figure with these dimensions, length, breadth and height of a cuboid are said to be dimensions. Remember this terminology, my children. Dimensions would be like the shape you see in the figure 13.2f. Okay, my children. So the sum of the areas of 6 rectangles is area of the rectangle L. Area of the rectangle 1 is equal to L into H. Area plus area of the second rectangle is equal to L into B. Area of the third rectangle is equal to L into H. Area of the fourth rectangle is equal to L into B. Area of the fifth rectangle is equal to B into H. And area of the sixth rectangle is equal to B into H. By adding all these areas, we get 2 into LB plus 2 into BH plus 2 into LH. By taking 2 as common factor from these three terms, we get 2 of LB plus BH plus HL. This gives us surface area of a cuboid, that is equal to 2 into LP plus BH plus HL. Please remember this formula, my children, to find the surface area of a cuboid. Okay, my children, memorize this formula well, where L, B and H are respectively the three edges of the cuboid. Okay, my children, these are the edges of the cuboid. Note, the unit of area is taken as the square unit because we measure the magnitude of a region by filling it with the squares of side of unit length. Okay, my children, do you remember this point? The area of a plane figure always measured in the square units. Remember this point, my children. Okay, my children, right. For example, if we have a cuboid whose length, breadth and height are 15 centimeters, 10 centimeters and 20 centimeters respectively, then its surface area would be 2 of L into B. Yes, 2 into LB plus BH plus LH. In that formula, here L is equal to 15, B is equal to 10 and H is equal to 20. We substituted these three values in that formula. Then we get this step. Okay, my dear children, understand this step. Centimeter square. That is equal to 2 of 150, 15 into 10. What is the value of 15 into 10? 150 plus 10 into 20. What is the value of 10 into 20? 200 plus 20 into 15. What is the value of 20 into 15? 300. Understood this step, my children? Centimeter squares. That is equal to 2 of, by simplifying the three numbers in the brackets, what will you get here? 150 plus 200 plus 300, 650 centimeter square. Understood this step, my children? Right. That is equal to 2 into 650. What will you get to? 1300. Yes, sir, my children. So 1300 centimeters square. This is the surface area of the cuboid. Understood this point, my children? Right. Recall that a cuboid whose length, breadth and height are all equal is called a cube. Yes, sir, my children. In a cuboid, if length, breadth and height all are equal, then the cuboid is said to be a cube. If each edge of the cube is A, then the surface area of this cube would be 2 into A into A plus A into A plus A into A. Yes, sir, my children. That is 6A square. See the figure 13.3. See here. This is a cube and we have used 6 square of length A units, giving us surface area of a cube is equal to 6A square. Please remember this formula, my dear children, to find the surface area of a cube. Memorize this formula well, where A is the edge of the cube. Okay, my dear children, right. Suppose out of the 6 faces of a cuboid, we only find the area of the 4 faces, leaving the bottom under the top faces. In such a case, the area of these 4 faces is called the lateral surface area of the cuboid. Okay, my children. There is a small difference between surface area of a cuboid and lateral surface area of a cuboid. Lateral surface area of a cuboid means the sum of the areas of 4 faces, leaving the bottom and top faces of the cuboid. Okay, my children? Right. So, lateral surface area of a cuboid of length L, breadth B and height H is equal to 2LH plus 2BH. If you add these two areas, we get lateral surface area of a cuboid. Let us take two common factor from these two 2h common factor, then we get 2 of LB plus 2 of L plus B into H. Okay, my children, right. Similarly, lateral surface area of a cube of side A is equal to 4A square. Okay, my children, remember these formulae to find the lateral surface area of a cuboid as well as lateral surface area of a cube. Lateral surface area of a cuboid is 2 of L plus B into H, whereas lateral surface area of a cube is equal to 4A square. Okay, my children, memorize these formulas well. Keeping in view of the above, the surface area of a cuboid or a cube is sometimes also referred to as total surface area. Okay, my children, surface area of a cuboid or surface area of a cube sometimes also referred to as total surface area. Okay, my children, understood this point? Right. Let us now solve some examples. Okay, my children, to understand these concepts well, let us take some examples. See the example 1. Mary wants to decorate her Christmas tree. She wants to place the tree on a wooden box covered with colored paper with a picture of Santa Claus on it. See the figure 13.4. Observe this figure, my children. This is a Christmas tree which is placed on a wooden box covered with colored paper. Okay, my children. She must know the exact quantity of paper to buy for this purpose. She wants to know the exact quality of paper to buy to cover this bottom, okay, wooden box. If the box has a length, breadth and height as 80 centimeters, 40 centimeters and 20 centimeters respectively, how many square sheets of paper of side 40 centimeters would she require? Understood this point, my children? She is purchasing a square sheets of paper of side 40 centimeters. Then how many square sheets of paper such papers are required to cover this wooden box? Okay, my children? Right. Now come to the solution part. Since Mary wants to paste the paper on the outer surface of the box, the quantity of the paper required would be equal to the surface area of the box, which is of the shape of a cuboid. Yes, sir, my children? Right. If the box here, if you observe the box, wooden box, it is in the shape of a cuboid. So to paste the paper on the outer surface area of the box, the quantity of the paper required is equal to the surface area of the box. Yes, sir, my children? Is this point clear? Right. The dimensions of the box are length, that is equal to L is equal to 80 centimeters, breadth, that is equal to B is equal to 40 centimeters, height, that is equal to H is equal to 20 centimeters. Okay, my children. Then the area of the surface area of the box is equal to 2 of LB plus BH plus HL. Okay, my children, do you remember this formula? Surface area of the box formula? Yes. So in this formula, let us substitute L, B and H. Okay, my children, right? That is equal to 2 of, see the first term in the brackets LB. What is the value of L here? 80 into, what is the value of B here? 40. So 80 into 40. Understood the first term, my children? Right. Plus, come to the second term. What is the second term here? BH. What is the value of B here? 40 into, what is the value of H here? 20. So 40 into 20. This is the second term. Understood the second term, my children? Right. Plus, come to the third term, HL. What is the value of H here? 20 into, what is the value of L here? 80. So 20 into 80. Understood this third term, my children? Centimeter square. Here we are writing the square units because we are finding the surface area of the box. So here units are centimeter square because here length, breadth and height are in the centimeter. So we write here centimeter square. Okay, my children, understood this step? Right. That is equal to 2 of, let us simplify each and every term. What is the value of first term? 80 into 40. What do we get here? 3200. Understood this 3200, my children? Right. Plus. Come to the second term. 40 into 20. What is the value of 40 into 20? Yes, 800. Understood this 800, my children? Right. Plus. Come to the third term. 20 into 80 is there. What is the value of 20 into 80? Yes, 1600. Understood this is the third term, my children? Right. Centimeter square. Understood this step, my children? Right. That is equal to 2 of, let us simplify these three terms in the square brackets. Means we have to add all these three numbers. What will you get? 3200 plus 800 plus 1600? Yes, 5600. We wrote that units as it is centimeter square. Understood this step, my children? Right. That is equal to 2 into 5600. What will you get here? 11,200. Understood this number, my children? Centimeter square. We wrote the units as it is. Understood this step, my children? Right. The area of each sheet of paper is equal to 40 into 40 centimeter square because the sheet is in the shape of a square and its measurement is 40 centimeters. So 40 into 40, that is a 1600 centimeter square. This is the area of the square sheet of colored paper. Okay, my children. Therefore, number of sheets required is equal to surface area of the box whole divided by area of one sheet of paper. Okay, my children, understood this step? Right. That is equal to, what is the surface area of the box? We have already found here 11,200. Let us substitute that number here. Whole divided by area of one sheet of paper. We have found that also. That is 1600 centimeter square. So write that number in the denominator. Understood this step, my children? Right. Now let us simplify this number. What will get here? 0, 0 cancels. Here 0 gets cancelled. Here 0 gets cancelled. So 16 one times, 16 7 times. Yes or no, my children? That is equal to 7. Understood this step, my children? Right. So she would require 7 sheets. Understood, my children? Right. Now let us take an example. Okay, my children. Hamid has built a cubical water tank with the lid for his house, with each outer edge 1.5 meters long. Understood this step, my children? Understood this sentence? Right. He gets the outer surface of the tank excluding the base covered with square tiles of side 25 centimeters. See the figure 13.5. See, observe this figure, my children. This is a water tank. What is the shape of this water tank? Yes, cubical water tank. So this question is based on a cube. Okay, my children. Find how much he would spend for the tiles if the cost of the tiles is 360 rupees per dozen. Understood this question, my children? Right. Now come to the solution part. Since Hamid is getting the 5 outer faces of the tank covered with the tiles, yes or no, my children? He has to cover these 4 sides and the lid with the tiles. So he has to get the area of the 4 outer faces of the tank. He would need to know the surface area of the tank to decide on the number of tiles required. Okay, my children? Understood this sentence? Right. Edge of the cubical tank, that is equal 1.5 meters. that is equal to 150 centimeters. Okay, my children, understood this point? Because here we are converting this meters into centimeters, because the length of the side of each tile is given in terms of centimeters. That is why we are converting this meters into centimeters. How many meters equal to centimeters? How many centimeters make 1 meter? Yes, 100 centimeters. 100 centimeters. 100 centimeters makes 1 meter. This is the relation between centimeters and meters. Do you remember this point, my children? So we are converting this meters into centimeters by using this relation. So we get 150 centimeters. Understood this point, my children? Let us assume that is A, edge of the cubical tank. Okay, my children, understood this step, right? So surface area of the tank is equal to 5 into 150 into 150, because he has to find the 5 outer surfaces of the tank. That is why we are multiplying by 5. Area of a square is equal to 150 into 150. Yes or no, my children? So 5 into 150 into 150 centimeter square. Understood this step, my children? Right. Area of each tile is equal to side into side. Yes or no, my children? Because tile is in the shape of a square. So area of the square tile is equal to 25 to 25 centimeter square. This is the area for each tile. This is surface area of the tank. Okay, my children? So the number of tiles required is equal to surface area of the tank by area of each tile. Okay, my children? Understood this point? Right. That is equal to, what is the surface area of the tank? Yes, 5 into 150 into 150. We substituted that value in the numerator, divided by, what is the area of the each tile? Yes, 25 to 25. We substituted this number in the denominator. Understood this point, my children? Right. Now let us simplify these numbers. Here 25 1 times, 25 1 times, here 25 6 times. Okay, my children. Similarly here also 25 1 times, here 25 6 times. Then what will get here? 5 into, in the numerator what will get? 5 into 6 into 6. I am doing this part in the rough work. What will you get here? Yes, 160. 180. So this is the value of 5 into 6 into 6. That is equal to 180. Understood this point, my children? This is the number of tiles required. Okay, my children. Now come to the cost of 1 dozen tiles. That is, cost of 12 tiles is equal to 360 rupees. This is given in the question itself. So let us find the cost of each tile. Therefore, cost of 1 tile is equal to 360 by 12. Understood this step, my children? Right. Now let us simplify this number. 12 1 times 12. 30 times. So that is equal to 30 rupees. This is the cost of 1 tile. So how many tiles are required? 180. Yes or no, my children? So the cost of 180 tiles is equal to 180 into 30 rupees. That is equal to 5,400 rupees. Understood this point, my children? Right.